problems regarding one from okay, this one. One was question number 5 and other was how noise cancellation work. So we will do this in the end of the class so that everyone who come either late, she can be able to understand this concept. Okay, so we will discuss these in the end. First, let's start with the NCRT problems. Do you guys have any doubt in any part of this chapter?
Sir, can you explain that visually impaired that part, sir?
Visually impaired. Okay, this was like many person, like there was one person named as Louis Braille. He does not had eyesight. Okay, so he was visually challenged. So similarly, there are many people who face this problem. Like it may be from their birth, it may be due to some disease, or it may be due to some accident. So due to which they lose their eyesight, or they lose the power of their eyesight. What does mean the losing power of eyesight? That means they can they have little bit sensation, like if they open their eyes, they have little bit sensation that there is something, but they cannot see very clearly. Okay, so there is one person, like I have noticed one person in IIT Delhi. So he used to walk with the help of stick, but he is not completely blind. Okay, so he walks through whole from one place to another. Like he go from his hostel to the classroom, and he also comes to library. Okay, so what he has a less eyesight. Okay, so he cannot see everything clearly. That's why he is using stick. Okay, to confirm if there is something or not. Otherwise, he has little bit of idea, like very less idea that there is some object or anything. Okay, so likewise, there was an scientist named Louis Braille. He discovered a method through which the visually challenged person can read or write. Okay, so this the thing he discovered is known as Braille system. Okay, so what is this Braille system? So he has a tablet which has 26 dots. So these are some points which are out like coming out of the paper. Like you can say some mm,
So like bulging out.
yes, bulging out. Correct. Thank you, Manasvi. So there are some bulge out of this slate, the rectangular slate. So there are 26 dots with the help of which, like as you know how to read and write. Okay, so if you write hello, so you okay, not hello but hello. So you know the meaning of HELLO and the whole hello. So you know how we arrange HELLO. Okay, so that we get whole as a hello. So likewise, there is some arrangement in this trail system with the help of which they can read and write. Okay, so this is the source of communication for visually challenged person. Apart from that, they like how so there is one thing, like you have all kind of senses. Okay, first can you tell me what kind of senses do we have?
So five.
Five senses. Okay, what are that? One is
Sir,
eyesight.
touch.
So eyes.
Sir, touch.
Eyesight.
Sir,
Other is
eyesight,
touch. Okay.
Hearing.
touch,
Okay.
Tasting.
Okay. Good.
hearing, taste, smell.
Smell. Okay. So these are five kind of senses we have. So we can never imagine the pain of someone who does not have even one of these. Okay. So we should be grateful that we have all of these. Okay. So every sense is important in its own way. If you do not have even one sense, there is huge impact in your life. Similarly, let's say a person like Louis Braille does not have eyesight. So how he manage his whole life if he cannot see what is outside? So that way, like our whole brain is distributed with between the eyesight, touch, hearing, tasting, and smell. But if this Louis Braille does not have eyesight, so our senses are now divided between touch, hear, taste, and smell. So these senses will highlighten. Okay.
Sir, if they don't, if they lose the sensor, they get to use their other senses more effectively.
More effectively, correct. Okay, so due to the loss of this sense, they are using other senses more effectively. Okay, so that way we can say they have uh, highlighted senses, other senses apart from eyesight. Okay, is this clear now?
Yes, sir.
Okay, you read this whole para. After this, what is the braille system and all? Or and have you guys read about, like, I do not check your homework, right? From next class, I will remember to check your all homework. Now tell me, have you read about how to take care of the eyes?
Yes, sir.
Okay, can you tell me how?
So not using mobiles and TV for long time.
Okay,
We should not rub
or
our
you can
eyes,
say
sir. Should not rub our eyes.
no. Okay, no excessive rubbing.
And also we should not look at like light or laser directly.
No.
Sun.
Uh, Sir, we should not sit anywhere where there's lots of dust, otherwise it can irritate our eyes.
We shouldn't
Correct.
be
We
reading when
should,
there is dim light.
Correct. Very good.
sir, we should not uh, do rubbing.
Okay,
Sir,
there
we
is one
shouldn't.
thing.
We should not see light or laser light directly.
Correct. This is also good. This is a good observation that
Sir,
you should.
sir, torchlight in our eyes.
Yes, torchlight also. Any concentrated
And
light. You can say any
we should not
concentrated light.
in the dark or see a gadget in the dark, otherwise it can damage the eyes.
Yes, it can damage our eyes because that way our whole eyesight is focused to that part and it can cause much strain to our eyes. Right. This laser one is also good. Like why we should not see directly to the laser? Can someone explain? Like when we use lasers in our labs, it is always advised that you
So because it
keep
is a kind of radiation.
light, all kind of lights are radiation. Okay,
And it
light
points
ray.
to one single place.
Yes, you can say that its whole energy, its whole energy is concentrated to that single beam. Okay, you know that the beam of laser is so small. Like beam is large, but the spot it create, that is very small, very small. So the whole energy is concentrated to that single spot. What do you mean? That let's say you have a large, like there is a headlight of a car. Okay, so there is a headlight of a car. I'm making it like this. So it is spreading like this. Okay, in odd direction, and let's say it has 50 watt power. Do you know the concept of power?
Yes.
No, sir.
So
So,
work by
and
time.
Yeah. So watts is so is it watts?
it
So
we
power is
in
work by time.
So is it 50 watts? What is W?
we when we write full form as
Okay.
WATTS, then we write
Or
watts, but
it's
in short
watt.
form,
So is it watts? Volts into ampere.
yes.
Okay.
No. What you said? Can you repeat?
Like, like you said, what's power? I mean, like power is watts, and watts is volume into ampere. No, voltage into ampere.
Yes. VI, that is volts into ampere.
Ampere.
Uh, Manasvi was saying something. Yes, Manasvi.
So power can be work by time.
Yes. Work by time is energy, and energy by time is
So it's power.
work by time. Okay. Okay. Joule. You saying work per tower time. Hmm. Work per unit time is energy. Okay. Fine. Power is work by time. Correct. My bad. So why I was explaining that this is 50 watt power. So Ashwat asked that what is power. So when any object emit light, when any object have voltage and it has current, so it has some power. What do you mean by power? Let's say you are sitting in a car and the car has motor. So car is driving you. Okay, like you start a car and you drive it. So the motor has power. With the help of it, it is carrying you and whole of the car with itself. So it has some power. Like you are like mm, you are pulling a rope. Let's say you are pulling a rope which is attached to some heavy object. So you are applying power. You are applying power to pull it. Okay. So I think it is clear that what it is meant by power. So similarly, when there is some light and it has voltage and current. So forget about voltage and current. When any object emits light, so this light can be measured in terms of power also. Okay. So that means this
Okay, sir.
light is of 50 watt power, and this whole power is distributed in every direction. You cannot say that this single ray is consists of 50 watt power. So this power is distributed in every direction. I think you know that the bulb which are there in your houses, they they contain the rating as power. Have you seen it?
Yes.
Yes.
Yes. 100 watt, 50 watt. Okay. Okay. These are powers that the rating that comes with the bulb, right? There is also 10 watt power bulb also. So it is the intensity, the energy it emits per unit time. Okay.
Okay, sir.
So now what here happen is that this headlight is emitting a light. Since this headlight is rated, this is rated as 50 watt power. So that means this headlight will emit light which has 50 watt power, and this light is distributed in every direction. This power is distributed in every direction. Okay. Likewise, I take a single laser light. Okay. Since this light is also, this is only a single, a very narrow beam. Okay. Since this light is very narrow beam and it is also rated as 50 watt, that means the energy which was the energy or the power which was like spread in all directions is concentrated to the single ray.
Sir,
Okay.
then there is
So now,
uh,
okay, wait. So now this whole power is concentrated to single ray. So you can imagine that 50 watt, you search for like this, do this Google, that how much intensity, how much light does the 50 watt bulb emit. So this whole light is concentrated to the single ray, which is very narrow. And if it falls into any part of your eye, it will surely get damaged. So I can tell you how much is this 50 watt. So we use in labs, we use laser of power rating 50 milliwatt. Now can you tell me what is 50 milliwatt?
It's 1,000 part of 1 watt.
1000. That means 0.050 watt. Okay. This power rating. Uh, okay. So this is the power we use in the lasers which are there in the labs. Even then it is very uh, uh, we have to use these lasers with very caution, that uh, this laser light should never be put in the eyes. Okay. Similarly, there, let me search for the toys. Okay. So you must have seen toys power rating. Okay, less than 1 milliwatt. Fine. So the power rating of the toys we get in the market. So these lasers have intensity, their power less than 1 milliwatt. That is 0.001 watt. Okay, even this much intensity is harmful. So you imagine if someone has like someone put a laser of 50 watt power into your eyes, it will get damaged. It will wholly get damaged, even with a single strike. Fine.
So
That's why
can
laser.
such a laser cause fire as well?
Yes, what?
So can such a laser cause fire?
Yes, of course, that laser can cause fire. How? Have you tell me one more example in that case light can be used to create fire?
It's a
Do you know?
magnifying glass.
Magnifying glass, right? So what magnifying glass is doing? The it is concentrating the whole.
Concentrating.
Yes, exactly. So it is concentrating whole light into single point. Similarly, the laser also has a whole intensity concentrated to the single point. Okay, so this is very harmful, right?
So can
So
it start fire on anything or like just small paper pieces and all?
yes, it depends on the object also. Okay, so if the object is kind of like paper, so what happen if a high energy is provided to the paper, it can catch fire. Whereas if you provide this high energy to rubber, it won't. So it depends on the material also. Okay,
Okay.
but it is very high energy. Even with high energy lasers, it can fully cut human also or any object. Lasers are used in many industrial objects also to use for cutting. Okay, fine. So we are over with laser. Any doubt?
No, sir.
No, sir.
Good. Okay, we were discussing about the how we should take care of our eyes. Okay, you guys gave me very good points. Very good. So we should not use mobile phone or any Blu-ray object in the dark room. We should not sit more in the dust area because it can cause infection to the your eyes. Okay, who is this? Right at the beginning. Hmm. Now let's start with the first question number one. Tell me, suppose you are in dark room. Can you see objects in the room? Can you see objects outside the room?
Sir,
Sir,
we
we
It will
can
be
can
see
very
see
we
objects
can
in
see
the room
objects
because,
inside the room.
sir, because the
Yes, we can.
eyes, they don't get enough light when we're in a dark. So when we come
okay.
out, the sun gives us enough light to see. Like our eyes get, the eyelids get enough light to see in the light.
Very good. Good. Now second one, differentiate between regular and diffuse reflection. What are regular and diffuse reflection?
The regular reflection is one in which
The rays are parallel to one another in regular.
so the reflected rays are parallel to one another in a
They're
regular
in diffuse,
reflection,
they're not
and
parallel.
they're scattered in different directions
In different directions.
reflection.
Okay, you can say that regular reflection follows the laws of reflection.
Sir, it takes place on a smooth surface. Regular reflection and diffuse reflection takes place on a rough surface.
Very good. Regular-
Sand in diffused reflection I is not equal to R.
Yes, very good. Smooth. This is rough. I equal to R. I not equal to R. It's regular. Rays are parallel. Not parallel. Any other?
Sir, I is equal to R in reflection, regular reflection.
Yes. Okay.
And
And then does diffuse reflection mean the failure of the laws of reflection?
yes, sir,
Can you tell
because
me?
the
Yes.
angle of incidence is not equal to angle of reflection.
Very good. Now third one. Mention against each of the following whether regular or diffuse reflection will take place when a beam of light strikes. Answer
The
in
A
each
is
case.
Sir, A is regular
regular.
because it's a
A
smooth
is
surface.
Okay.
Sir, B is also regular.
Regular.
Sir, C is
Uh,
rough.
why B is regular?
No, sir, it's rough. Sorry, it's a rough surface.
So
Because
because it
they
has a
see.
spherical like shape, that's why it
Yes,
is
sir.
diffused.
Sir, but
You
isn't
can
it
say
sometimes a bit smooth?
what smooth? It's the chalk powder.
Yes, sir.
No, chalk
No,
powder
so
is
chalk
like
is smooth. Chalk is smooth,
chalk
not
is
chalk.
smooth. Yes, you can say chalk is smooth, but when it is broken into powder, it has very many kind of particles. Okay, so
Okay.
you must have seen that when we write in the blackboard and when we erase it, there are small particles which like uh, uh, fly in the air. Okay, the particles which are there in the air. So these are very minute particles present in the powder, which will reflect each ray coming differently. So we cannot say that this is a smooth.
Yes, sir.
Okay.
Sir, in
Is nice.
regular reflection, we can say that the rays are parallel, sir, because in the case of concave mirror, the the uh, rays meet after reflection. They meet at one point, and in convex mirror, the rays never meet, sir. After
But
reflection,
we
the
are
rays never meet.
discussing about plane mirror, right? So
Okay,
regular
sir.
and diffuse reflection are there in the plane mirror, isn't it?
Okay, sir.
So concave and convex, those are very different things. Okay, concave mirror is also smooth mirror, and convex is also smooth mirror. But their type of reflection they do, that is very different from the plane mirror. Okay. Now
Sir,
tell
can
me the
we do
cardboard
that
surface.
topic anytime?
What Manasvi?
So can we do that topic anytime? Concave and convex mirrors.
Is it there in your syllabus?
So not there actually.
Not there. Okay. So are you guys interested to study it now?
Sir,
Sir, we
Yes,
already
Aditya.
learned it in seventh grade. Like it will be like a revision for us. We know what this means.
Okay, very good.
sir, after this chapter, can we do chemical effects of electric current?
Yes, we will do the chemical effects of electric current.
Thank you, sir.
Okay, we will do it. So let me tell you a brief about the concave and convex mirror, and then like have you guys seen the ray diagram, the image formation by concave and convex mirror
Yes.
depending on the position of the object?
Yes, sir, we did.
You have done
Um,
fine. Okay, so the concave mirror is like this. What does it mean by concave mirror? That when a object is placed in a one side, then the bulged in. Okay, the reflecting surface of a concave mirror is bulged in. Whereas when we see the convex mirror, it is like this. Okay, so this is the difference between these two. That in concave mirror, the inner part is reflecting surface. We can say this inner part, this is reflecting. Whereas in convex, the outer part. Okay, outer part is reflecting. What happens when a ray of light comes out of an object? Okay, so it travels, you know that the ray of light always travel in a straight path. So it will travel like this and it goes like this. Similarly, one ray go like this. So this is ray tracing of a object. So if you guys haven't learned about it's okay. So let me tell you how it is forming. So this is how, these are the rules
Sir,
of yes, Aditi.
will we have this for a test?
Not test. I'm just like, you guys told me that you are interested to like read about it, then I'm just telling you. This is
Okay,
not in
sir.
your test. Okay, fine. Don't worry. So let's not go to the ray diagram. Let's just see the broader picture. That when can you guys tell me where we use the concave mirror and where we use convex mirror?
Sir, convex is used in concave mirrors are used in car mirrors and the tools the dentists use.
um, Uh,
In car
Concave,
mirrors, in the back mirrors, we use convex to
Okay, sir.
get a large view.
and concave mirrors, I think, do we use it for
Sir,
shaving mirrors?
spoon.
Yes, in spoon. Okay.
The shaving mirrors,
So
Yes, sir. We use
saving mirrors. So
yeah.
we
concave
use
mirror and
concave
shaving mirror.
mirror to see small objects,
So they're
or we
also
can
using.
say it is used to magnify objects. What does magnify means?
Uh,
Yes, for sure.
sir, converts light rays, sir.
So it shows a
Yes.
smaller object like big.
A
It appears big.
big. Correct. So concave mirror is used to magnify, that is making the object bigger. So let's say how it is helpful. It is helpful for dentists. So with our normal eyesight, we cannot see if there is any small, like some what there is
Cavities,
cavity.
inflammations,
Yes, correct. Cavity,
inflammations.
pyria, and some other small like dark part or anything, like, yes, cavity. So with our normal eyes we cannot see small cavities which are there in your teeth, but with the help of this magnifying object like concave mirror, they with the help of this concave mirror they can magnify the view, and they can see that if there is some cavity or not. So basically concave mirror is used to magnify objects, whereas the convex mirror. So why we are using convex mirror as a mirror of vehicles? Okay, as a back mirror or as a side mirror. Can you
Rear
tell me?
view mirrors and side view mirrors, sir.
Yes, can you tell me why we are using these in that part?
Uh, to get the view of the larger traffic, sir. Like if we can get the view of more traffic, sir. Like
Okay, very good.
So
Larger
it's
view.
opposite.
for like to view the entire like if we're going on a highway, sir, we can view the entire road, sir.
It shows everything smaller.
Everything smaller. Very good. Smaller view in large area. Okay, so convex mirror are used to like get, like there is a large view. Okay, these are used as a side mirrors because there is a large view behind the like truck or any vehicle. So we need to know the small details, like uh, because if there is a large view, we need all that view in a small area, so that we can clearly identify if there is some vehicle behind or at the side. Okay, so basically convex mirror is used to contain the large view in small area. It magnifies down. Okay, it makes the object smaller, whereas concave mirror makes the object bigger. It magnifies. Okay, so this is the difference between concave and convex mirror.
So what
Now
are the images for like virtual real?
what are
Images formed.
I didn't get you. What you are saying? Images?
So images formed by concave and convex mirrors.
Okay. So there is like it depends on the position of the here. So I'm not making a ray diagram. So when an object is placed, this is center of curvature. This is focus. So you guys do not know, maybe do not know about center of curvature,
We know, sir.
but it is double. Yes.
We know, sir.
Center of
Okay. So
like,
center of curvature is double of the
Sir,
focus,
if we
right?
yes, sir. Yes, sir.
So double of the focus. This is the position of focus, and this is the position of. Yes, sorry.
so
Yes,
I
Karthik.
always have this doubt. Is it called as focus or focal point? And when I asked ChatGPT or Google, there was nothing such as focus. I was getting so confused. Is it focal point or focus?
When we discuss about this point,
Okay.
then it is focal point. But generally, when we when we are talking about it, we never say focal point,
Okay.
but we say it as focus.
So
Okay,
in
it's just
scientific,
about
uh,
the way we talk.
okay. For the sake of science, we should say focal point, and just for normal usage, we say focus. Is it so?
Yes, you can say
Okay.
that. So when an object, this is object. Let me take two different colors. Let's say the yellow one, this is object, and the green one is image. So when
Image.
an object is very far from the mirror, then it is focused on the focus,
Sir,
or you can say focal point. So the image will be here, near the focus. When the object is at the center of curvature, let's say there is an object which is sitting at the center of curvature, you will get the image same at the same position. And these two, like
sir, is it a
these,
real image or a virtual image?
yes, telling you that only. So when an image is formed at the same side, at the same side as that of object, then
Sir,
it is a real image.
sir, it is formed on the screen, right, sir? It's not like on the side, but it's on the screen.
But yes, you are correct that it is formed on a screen, but it is on the same side, right? If this I can say
Yes, sir.
left, this I can say right. So both object and image are on the left side, isn't it?
Yes, sir.
Yes, it is correct that it it will be formed on a screen or any opaque surface. Without it, we won't be able to make out the image. Okay, but I am talking about the sides. Like if this is left, this is right, then the object and mirror, if let's say both the object and the image are on the right side, that means the image all is real here. Let's say I am taking object in the left side and image in the right side, that means that image is virtual. Okay, so likewise
Sir,
here, if
so here, the image is not erect, right, sir? It
inverted,
is
yes,
inverted.
it is inverted, yes, and with along with the position, the magnification also changes. Okay,
Yes, sir.
so if an image is very far, then here very small image will be formed. So let's say if there is a object on the center of curvature, then its image will be formed at the center of curvature only, but in the inverted side. Similarly, let's say if an image is at the focus, then that image, it will be formed at infinity. Okay, what does infinity mean? That a very, very, very large distance. Compared to this distance, the distance of the mirror and the image will be very, very large. And if there is an object between focus and the mirror, then that image is virtual. That image is virtual. So can you tell
Sir,
me what is the position, what you position you should take of object so that you get a virtual image?
sir, it should be uh, more like closer to the mirror, sir. It should be very close to the mirror.
But I have told you the criteria. Tell me the criteria. Anyone?
It should be closer to the mirror, and it should be closer than the focal point, sir.
Is others listening or not? If you guys are not interested, then I won't tell.
Sir, we are listening.
It should be farther than the. It should be closer than the focal point, sir.
Okay. So let me repeat again. So if an image, I have drawn the the object. I have drawn the object in yellow, okay, dark yellow, and the image as green. So if an object is very far from the mirror, let's say far from the sorry, far from the center of curvature, then that image will be found here,
So,
okay, very close to the mirror. If the object is standing at the center of curvature of the concave mirror, that means the image will be formed at the same position only, but in the inverted direction. Up. If someone is standing like this, then he will be very inverted, right?
You can
If
observe this in a spoon, sir.
yes, you can observe this in spoon. Very good. If an object is at the focal point, then
The
its
image will be
image
at
will be
infinity.
infinity. Infinity means very large distance. Okay. If an object is between focal point, okay, like Karthik said, focal point, or we can say focus. So if an object is between focus and the mirror, that
Then then the image will be virtual.
yes, very good. So then the image will be virtual. It will be, if the object is to the left, then the image will become to the right. Okay. So in concave mirror, all images are real except when the object is placed between focus and the mirror, right? Whereas in convex mirror, every image is virtual. Okay, if this is object, the image will be found at this side. If this is virtual, image will be found at this side. Okay, there is no specific criteria. So now you should know that I was telling the uh, why I was telling that if object is placed far from center of curvature, at center of curvature, at focal point, and between focal point and the mirror. So it is just to tell you that all kind of images are formed are real except if the object is placed between focus and the mirror. Whereas in convex mirror, every image is virtual. There is no real image. And let's move to the one. So we were talking about cardboard. Tell me, is cardboard a smooth or a rough?
So,
It is
Rough, sir.
Ah.
Rough.
good. It is rough. Now,
If you-
marble floor with water
Regular,
spread
the
over it.
regular,
Smooth and polished surface.
regular.
Okay, match the following whether regular or diffuse reflection.
Sir,
Very good.
mirror
Okay,
is also
we
smooth. Regular reflection.
yes, it is regular and smooth. Mirror,
Piece of paper is
Regular.
Regular,
regular. Okay, piece of paper.
diffuse reflection.
diffuse.
Rough surface.
Yes, it is a rough surface. Now state the laws of reflection.
Sir, law
So
one
I
is
equals to R.
I is
I equal to R.
Angle I
Sir,
is equal
angle
to
of I
R.
is
angle of
equal to angle.
incidence, reflected ray and normal lie on the same plane.
Same.
Okay, all these lie in same plane.
Same
Very
plane.
good. Now, fifth one, describe an activity to show that the incident ray, the reflected ray, and the normal at the point of incidence lying in
Sir,
the
we
same
have to
plane.
draw
A
on a
mirror.
paper, sir. You have to draw on a
mirror.
paper.
Okay, very good. Mirror is very good example. Also, there is, you can say, the piece of paper.
Paper, sir.
Yes, it is also an activity to draw it on the paper. Mirror is very good example. Any other?
Sir, sir, in a dark room, if you turn on the torchlight towards the mirror, you can see the path of the light, sir.
But there is no reflection, right?
So light falling
Like
on
to
our
show
eyes.
that the incident ray and reflected ray and normal lie on the same plane. There's an activity on that.
Mhm.
So light falling on our eyes, by which we can see.
Okay, Manasvi, tell me what kind of thing we observe in our eyes. Is it reflection or
refraction.
refraction?
So it's refraction.
It's refraction. Okay, so let me tell you one thing that you must have observed that when light goes towards a mirror, it never passes through the mirror. Okay, so in mirror, the light gets reflected. That is, it is not passing through the mirror. Like you take a mirror and see the backside of the mirror, you will never observe that the light ray is coming out of it. Whereas in eye, what is there? What it is that there is a light entering into eye, there is a lens, and after passing to the lens, it is going to the retina. Okay, that means the light ray is passing through the eye. Okay, this is whole eye, and our eye starts from cornea. Okay, so it is passing through cornea, passing through uh, our pupil. It is passing through the lens. Okay, eye lens, and then it goes to the retina. That means it is passing through. So this passing through phenomena is refraction. And
Yes.
when the light ray does not pass and it goes to the same medium. So what is difference between reflection and diffraction? That the light ray going in light ray which comes out in the same medium is known as reflection.
Reflection.
Whereas when light ray travels to the different medium, one medium to another medium, then that is refraction. Okay. Okay.
Yes.
Now sixth one, a person 1 meter in front of plane mirror
So 2
seems to
meters.
be
2 meters away from his image.
So 1 meter.
very good. No,
So
it is
2
asking
meters.
dash
Sir,
meter away from
distance
the
from
mirror
image,
Two,
distance
sir.
from mirror to
Okay,
image
sir,
is
2
1
meters.
meter. So 1 meter plus 1 meter is 2 meter.
Yes, correct. So if this is 1 meter, if this is 1 meter in front of the mirror, the image is also 1 meter, and it is asking the person, it is asking the distance between the image and the object. So it will be 2 meters. If you touch your dash here
So
with
left.
right hand,
So
okay,
he asked this in the
The
test.
left
Sir.
and left hand.
Left and left.
left and left.
Asked in the
Very
test,
good.
right, sir?
Now C part, the size of the pupil becomes dash when you see in
Sir,
dim light.
increases.
So
Increases.
increase.
Increase.
Enlarges.
Large.
Enlarge.
Large. Yes, in large.
And birds have
Night birds have dash
less.
horns,
Less.
then
Less.
Sir, less, sir.
less horns, okay, then rods in their eye. What does this mean? Can you explain me?
Sir, because rods adjust to dim light, sir. Rods adjust to black and white light, and cones adjust to bright light, and they help in detecting color. Since the night
Very good.
birds don't have to detect the color in the dim light, they have more rods than cones.
Very good. Very good. Well explained. Seventh one. The angle of incidence is equal to the angle of reflection. It is
Always.
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 Okay. Okay. I have to raise this. Tell me, image formed by a plane mirror is
Virtual behind the mirror and at the same size of object.
okay. Virtual behind the mirror and enlarged. It is incorrect.
No, sir.
Virtual
No,
behind the
second
mirror
is
and the
correct, sir.
same size. Okay. Okay. B. Describe the construction of a kaleidoscope. Can
Sir,
you
we
describe?
have to have three.
Here it's a
Three,
device based on
mirrors.
the principles of
Construction.
multiple reflections.
Okay.
Construction.
Sir, it has 3 strips of plane mirrors.
Three strips of mirrors,
Oh.
sir. It is
Okay.
built in
Ashwat, let
construction.
Rohit speak. Ashwat, wait. Let's Rohit speak. Okay. Continue, Rohit.
So the 3 plane mirrors are fitted in a tube.
Mhm.
One end of this tube is closed by a cardboard disc
Okay.
or a cardboard disc having a hole in its center.
Mm-hmm.
Sir, and the glass plate is on the other end. So,
Other hand. Yes.
sir, the tube is closed. That's all, sir.
Tube is closed. Also, we put
Pieces of
small
glass.
colorful glasses, pieces of small pieces of glasses, colorful glasses at the other end. Other end where we have put the glass as a opening, like closing. Okay. So we see different kind of patterns in the kaleidoscope.
Sir, in
Draw
school,
a-
in multiple assessment, we had to make one kaleidoscope.
you have to or have you made?
Sir, I made, the teacher gave us three options. I did
Okay,
dispersion of light.
dispersion of light. Okay, how you did dispersion of light?
So the teacher told you take some water in a plain glass, glass,
Mhm.
and you place it in a dark room on a white sheet of paper and phone torchlight.
Okay, very good. That means with the help of refraction.
Yes, sir.
Do you observe same kind of phenomena somewhere else?
Sir, rainbow.
Rainbow, very good. So in rainbow also there is a water droplet. Because of these water droplets we see rainbow. Okay, the different colors which are splitted from the
That's
white
because
light.
the white light comes in contact with the rain, right?
It comes in the contact with the rain. Correct? Because after you never observe rainbow in a clear sky, every time there is a like rain, and like it should follows that criteria that along with the rain there is sunlight, so that in that case you will observe rainbow, because without sunlight there won't be any splitting or any white light. Very good. Now next is draw a labeled sketch of the human eye. Okay, there is no, okay, there is no. Fine, do this. This is your homework. Draw a labeled sketch of the human eye.
Is there a simpler way to draw it we can we can draw it without confusion in the exams?
Simpler way. So you guys must have must be using like protector and the uh, I forgot the
Compass.
compass. Yes, compass. So with the help of compass, you can, what you can do, you can make a simple arc. In that arc, erase the middle part. Like if I erase, it will go whole. So erase the middle part, make it a little bulge. Wait a second. Make it a little bulge. And you understood, right? I'm trying to make it a little
Yes, sir.
away, okay? And then you can make a lens is attached to the muscles, and it is all going through your optic nerves, right?
Yes, sir.
I I can think of this one only.
Sir,
Uh,
aquos,
It will do the work because we'll also have to explain it. So, yes, sir, this is.
we have to label it. That's it.
Yes,
Sir,
sir.
can we do the
okay.
next question, sir? We'll send you the picture of our drawing.
Correct. Suggest me, is anything else can be made in this diagram?
Sir,
Sir, the textbook one is
sir,
more
retina,
complex,
retina,
but
retina
sir,
and
yes,
optics
sir,
nerves.
optics and all that.
That is labeling. I'm asking like diagram. Okay, I haven't labeled it, right? So you were asking how you should draw. So I thought you only want the drawing.
Sir,
Sir,
inside sir, in
eyelids.
the textbook, inside the eye is something like a small semicircle or something.
Sir, blind spot.
Yes, sir.
Small semicircular. What are you saying?
Sir, should I show it to you?
Okay, so
Blind spots.
this is
Ciliary
ciliary.
muscles.
This is lens.
Lens.
Inside one is aqueous humor.
Aquos nerves.
Yes, sir.
Sir, blind spot.
Okay, there should be one.
Bulge.
There should be what I was missing. I was missing iris
Sclera,
and
cornea, iris, pupil.
Yes, I was missing iris and pupil. So you
Sir,
should
and
make iris and pupil
sclera
also.
at SCLERA. I don't know how to pronounce it.
Okay, this is a good
And
diagram,
cornea.
better than the last one. So there is a huge circular dome shape, and there is a. Okay, you guys do your diagram thing from textbook. Okay.
Yes, sir.
Now, 11th question. Gurmit wanted to perform activity 16.8 using a laser torch. Her teacher advised her not to do so. Can you explain the
Sir,
basis
the
of the
teacher
teacher's advice?
advised her not to do so because if we point the laser in the eye, it can cause a permanent defect in our vision.
Yes. We
Sir,
cannot say permanent, like I have told you that it depends on the power of the laser, but it can damage our eye. Like if you do repeated this laser incidents on your eye, it can permanent do so, but
Sir,
it
even
depends on the
with
power also.
glasses on, will the laser harm the eye?
Even if
Sir, with glasses on, the laser cannot harm the eye, right?
uh, glasses laser, that is a different thing. Like laser can be used in many ways. Yes,
sir,
this is a
Won't
good.
it
sir, in my
reflect
point,
the laser?
Yes, sir. Won't it reflect because the lens is there?
sir, what I think is that the glasses just pass the light through our eyes, but even if they are Blu-ray glasses, then they reflect the Blu-rays away from the uh,
Okay,
of
first thing, the Blu-ray you are saying. Also, I told you every wavelength, every light has different kind of wavelength. So what these glasses contain, they glasses contain specific type of coating which reflect these harmful UV rays or UV rays, or you can say blue light. Okay,
sir,
blue
UV
light,
rays for
which is
blue light are both are not the same, right, sir?
blue light is
UV,
different from UV. Like it is a mixture of some harmful rays. Okay, so this coating, what this coating do? This coating reflect this blue light. Okay, but this coating is never perfect because it is always a 90% or 90 above. It emits some light. Okay, it allows to transmit. Now Rohit was asking that why eye does not reflect laser light, right?
So the lens, sir. The glasses lens, sir.
Lens, lens. So I told you that lens do what kind of phenomena? Is it reflection or refraction?
Sir, reflection.
refraction.
I'm asking about lens.
Oh, sir,
Re-
refraction, refraction.
Yes, refraction. Refraction, that means it will allow to pass the light through it. Okay, so that
Okay.
means it won't reflect laser light,
Sir,
and this will fall. How it damage it actually? Can you tell me which part of the eye does the laser light damage?
The
retina,
iris.
retina,
Retina. Very good.
and ciliary muscles.
Not ciliary
Because,
muscle, but
sir,
retina
because
only.
if in my point of view, the ciliary muscles get damaged because too much of strain of the iris or pupil, sir. Because too much of light is getting focused.
No,
Like
that's not it. So
it will be
when
too bright. Right?
very high energy passes through this lens and it falls on the retina, so it damages the parts of the retina. Okay, it damages the retina. So here, if this, let's say, if this laser light has fall, then you will observe that there is a hole at this part. What does that hole mean? That there exist no longer the cells which were responsible to carry that signal to the brain. Can you tell me? I want to know one answer from you, that how due due to which phenomena does this cell get damaged? Can you tell me?
Sir,
Like Manasvi told me the focusing of light and burning. Can we say the same thing here also?
yes, sir.
Yes, sir.
Too much of
Yes. So we use
sir.
a lens. Okay, wait, Ashwin. So we use lens to focus the sun rays to a very small part, okay, very small part, so that causes burning. Similarly, this laser light is itself a very narrow beam, and the lens present in an eye will focus it more. If it focuses it more, then it will cause a burn in at the spot at which it falls. Okay, when it falls at the retina, it will cause a burn. Due to this burn, the cells which were present at this spot will die. If the cells die, then there is nothing left which will like transmit these
reflective
signals to
color.
the brain. Okay, nothing which can transmit the signal to the brain. There is one case of a lady. She used her phone in the dark, like after in the like in a dark room without any other lights, only the phone and herself. Okay, in the dark room. She used that phone for 2 years at maximum brightness. Okay, she used her phone in maximum brightness for 2 years. So later it was found that her eye had more than 1000 holes. Okay, so her eye had more than 1000 holes. So can you tell me what these holes are?
So by the concentrated light.
Yes, by the concentrated eye, the damaged part of the retina. Okay, the damaged part of the retina, right? So the what the lens do? Lens focus the image at different parts of the retina. Similarly, like if you are using phone like this, then the lens will focus the light at the upper part of the retina. If you are using phone like this, then the lens will focus the light ray to the lower part of the retina. Similarly, that lady had more than 1000 holes in her eye.
So
So you
then
can
how could she see?
so she can like you know that this whole area is retina. Apart from the holes she had, the 1000 holes, there were other part also that was like undamaged, but it won't be much long. Let's say if she used the same if she follow the same activity for 1 year or more, then she may lose the whole eyesight. Okay,
Sir,
so
if we have holes in our retina, does that mean that the image that we see, it's as if we are seeing some places that of that image which have holes? For example, if we are seeing a screen, sir, with
mhm.
holes in our retina, does it feel like when we are seeing an image, it's as if the image has the holes?
So this light ray is coming to the retina. It comes to different parts. Okay, it comes to the different part, but it depends on the how much intensity it is falling. So the lens, what is the work of lens? It focuses the light to the single point. So let's say it is focusing this light, this much light. So I am representing the thickness of the ray with the intensity. So it is focusing this much light to the this spot, but it also send some small intensity to other parts. Do you agree with me?
Yes, sir.
Yes.
So it sends small intensity to other parts of the retina. Let's say this point, the high intensity point got damaged. So this point got damaged. So now tell me what will happen.
Sir, the intensities will
Other
be
parts will help
shared to the
them to
other
see.
parts. Other parts will help.
No. So the lens will still focus the whole light ray to the this spot. But since there are no cells present, that means the signals which are reaching to these part, this part, this part, this part, this part, this part, this part, signals reaching to these part will go to the brain. And can you tell me the difference in the intensity?
So as it is less intensity, so the image will be blur.
Blur. Yes, it will be blur or very less intense. Okay, so you basically we can say it is blur. So this is the damage which goes due to the hole formation in our retina. So the intensity which she was like any person was observing earlier, it won't be the same. So I have exhausted my time. That's all for today. Do you have any doubts? If you have any doubt, you can stay. Others can leave.
Thank you so
Good night.
much.
Sir,
Sir, bye,
I
sir.
have a doubt, sir, not related to the topic. If you have
Bye.
time, can you tell?
Bye bye. Okay, ask.
Sir, does wavelength and frequency have a relation to the speed, like how fast, uh, like for radio signals, sir? Does
Mhm.
like is there power for radio signals? Like how does the power differ? Is there a unit,
Unit power is always in what?
sir? Of radio signals, sir. Like
So radio waves, these the power depends on the wavelength. Okay, so these have like we can directly relate that energy is given by hc by lambda. So you forget this whole part. You just remember that E is inversely proportional to wavelength. If any ray
okay, sir.
has higher wavelength, the energy will be what?
Low
Energy will be low. If someone has lower wavelength, what will be the energy?
will be high, sir.
Will be high. Yes.
Sir, so if
Okay.
the
So
frequency of a wave of a radio wave is very high, that means
mhm,
it will take much easier time to reach a distance.
very good. Yes, it will take very.
Sir, and like for
Hmm,
example, a small radio wave is sent to a distance of 5 kilometers, sir. So
hmm,
is there
hmm,
any
hmm.
chance that a radio wave can stop in the middle uh, because it cannot reach a distance?
It can be stopped depending on the loss it is facing. Like any radio wave traveling, it suffers an attenuation. Attenuation means the loss. So if the loss is very high, then it may be possible that the radio wave won't reach to the other point. Okay.
Sir, because that's why they put
Now you can think like you can think that higher frequency means higher energy. So why we are not using higher energy to transmit a signal? Because higher energy means that the signal how whatever the loss the signal will reach.
okay, sir.
No, no, I'm asking that you must have this doubt.
Yes,
Isn't
sir.
it good? Isn't it good that we use high energy waves from one point to another? That way, if there is some loss in the surrounding, it won't affect much, isn't it?
It will affect, I think, sir.
How?
Sir, like if we use high energy radio waves, it can
Mhm.
harm the aerial life, like not like in the air, sir, like birds.
Let's say we are not considering about environment. We are very bad people. We are concerned with our profit. Okay, it does not matter to us what will happen to the environment. Now, as a businessman, tell me, you want to increase your business, so you want to have good connectivity, and you want to send a radio wave so that you have a good business. So tell me, can you, will there anything, is there any effect when we send high energy to the one point to the
Sir,
another?
high energy means the energy will be wasted, sir. So maybe the usage of other like panels or like other type of material that bounces the like that
Okay,
can
so there
send.
is a simple answer to it. You will encounter this in your later classes that with higher energy, the loss it suffer. Okay, the loss it suffer is higher. That if you there is a particular kind of frequency, if you send your signal at that frequency only, okay, it is calculated. Like all these are calculation. So if there is according to the calculation, may be some particular type of frequency. If that frequency is sent, then you will have the very good connectivity. But let's say you send a very low frequency, that means it does not have energy, it will be lost in the environment. Let's say if you send a very high frequency one, so that also will suffer a great loss in the environment. Why? Because there is a direct relation of attenuation, which is the loss of energy with the frequency.
Sir, then,
Did you go?
do satellites use higher frequencies to send the signals to the Earth, or do they use
So
normal?
satellites, there is a vacuum in the between atmosphere and satellite. So these laws does not depend on vacuum. So that's why they are sent in the high energy from the vacuum, which can pass through it.
Okay, sir. Thank you.
It won't lose. Okay. Bye bye. Good night.
Bye, sir.